Hello my dear students. So in my last class I was explaining about gravimetric analysis. So there we saw what is meant by gravimetric analysis. So to say it in simple words, gravimetric analysis means to measure the mass of a compound or a substance which is under examination. Okay, so gravimetric analysis involves the determination of the amount of some constituents of a given sample by weighing. We are going to weigh and determine how much amount of compound is present with respect to the mass of the substance or a constituent which is present in it. Okay, so in this method, so the constituent to be estimated is separated from the sample in a solid form which has known percentage composition, and thus it is made suitable for weighing. So this is what is going to be done in gravimetric analysis. So we further discussed about the most widely used method for getting solid form in precipitation method. Okay, so precipitation method is a one familiar method which we are going to use to get a solid compound. So when we have to weigh a compound, when we have to measure the mass of a compound, definitely it should be in a solid state. Okay, so if it is in a liquid state or if it is in gummy nature, we cannot weigh or we cannot measure the perfect amount of mass of the substance. Okay, so for that reason, so it has to be converted into pure solid. Either it might be amorphous or crystalline, that is irrespective of that. Okay, so it might be a amorphous compound or it might be a crystalline compound, but it should be in the solid state. If it is a liquid, then we are going to measure it and express it in terms of volume. Okay, so we are not going to measure or express in terms of mass or weight. So as the gravimetric analysis is a method of analysis in which we are going to measure or weigh the given sample and estimate it in terms of weight. So much amount of compound, say for example 1 gram or 10 gram or 25 gram of compound is present. So we are going to report the result in terms of grams or in terms of weight, how much the constituent compound is present. Okay, so for that reason we have to convert the sample or the substance into a pure solid form. For that purpose we are going to use precipitation method. Okay, so in our last class we also discussed about what are the steps involved in precipitation method. Okay, so the first what is meant by precipitation was discussed. So there, to get precipitation, so we are going to use or the sample is going to get dissolved in the water to prepare the solution of a known concentration. Then we will choose a precipitant. We are going to choose a precipitant to give a precipitate of the known composition. Say for example, we took an example of barium chloride. So when barium chloride is added dropwise into the sulfuric acid, so we are going to get the barium chloride converted into barium sulfate. So where the barium sulfate is a solid. Okay, so the barium sulfate is going to get precipitated out and thereby evolving the hydrochloric acid. Okay, so hydrochloric acid is going to get evolved. So this was one example which we discussed in the part of precipitation, that is barium is precipitated as barium sulfate by using one normal sulfuric acid as a precipitant. So here sulfuric acid is called as a precipitant and barium is going to get precipitated as a barium sulfate. And another example what we saw was the ferric iron which is precipitated as ferric hydroxide. So when ferric hydroxide is heated, so it is going to form the ferric ion along with the removal or elimination of a water molecule. So here Fe2O3 will be precipitated and the dried precipitate will be ignited and weighed. Okay, so and thereby we are going to measure the mass. So these are the two different examples which we saw under precipitation. and we saw what are the technique for obtaining a quantitative, pure, stable, stoichiometric crystalline precipitate by studying 7 points. Okay, so I am repeating, I am glancing all the topics which I discussed in my previous class in detail, because we had a long gap of online classes. The last video which I uploaded was at the last week of September, I think, because since your academic year commencing date has been postponed, we had some confusions in doing the classes, online classes for first students, because we were expecting some more students are going to get admitted, so that we will wait for the newcomers. So we were waiting, and since it was a long gap, I am revising the topics which I discussed in my previous class briefly. Okay, so next we saw the other next steps what are involved in the precipitation method. So the second step was filtration. Okay, so once after precipitate has been formed, we have to filter it. Okay, so filtration of a precipitate is done either by using ashless quantitative filter paper. We can use a filter paper. I think you all have seen Wattman filter paper. So by using that Wattman filter paper and filtration funnel, that is a glass funnel, so we can filter it, and then by drying it, so we can weigh the sintered glass crucible. Okay, so by this way also we can measure the mass of the compound. And further, before doing that, so we have to do the purification. So the purity of the precipitate is an important aspect for successful gravimetric determination. Okay, so we have to purify before doing the gravimetric analysis. And the next step was once after it is purified, we have to dry it. There should not be the presence of moisture or any water molecules, any content of water. Okay, so say for example, if we are using water for the purification, if we are repeatedly washing the precipitate what we have got, so we have to remove all the water molecules which are present in that precipitate. So for that purpose we have to dry it. Okay, so we have to dry it completely, and it should be ignited if it is needed. Ignited means it is burnt by taking it in a sintered glass crucible. We can keep it in a woven, or we can keep it in heating mantle also. By keeping it in a heating mantle, the sintered glass crucible will be kept in a heating mantle, and it will be ignited, so that all the water molecules which are present, so that has to be removed. And by igniting we can also remove some impurities also. Okay, so say for example some low boiling point impurities are present, so those impurities will be evaporated, so that it one way also purifies the compound. And the next step was after drying and igniting, so it has to be cooled. Directly we should not go and keep it in a balance and weigh the sample. Okay, so once after it is ignited, we have to cool it. So the sintered glass crucible or silica crucible containing residues is cooled to room temperature in a desiccator. We use a desiccator to cool the sample. Why we will use desiccator means, so desiccators are vacuum containers where they will not allow any moisture or the environmental air to come in contact with the sample or the substance which is under examination. For that purpose, say for example, if the precipitate or the compound which we are analyzing, if it is moisture sensitive, then it will again absorb the water molecules in the moisture which is present in the environment. To avoid that, we have to keep that particular substance in the desiccator. If it is not moisture sensitive, then we can dry it, or we can keep it in the open place itself to bring it to the room temperature. Okay, so if it is moisture sensitive, then we have to keep it in the desiccator. Once after it comes to the room temperature, so what we are going to do is we are going to weigh. The cooled crucible is weighed accurately, so the mass of required constituent can be calculated using stoichiometric equations. Okay, so this is where we stopped in our last class, and in today's class, so let us discuss about what are the theories of precipitation. Okay, so till now we saw different steps which are involved in the precipitation method. So the different steps which we are going to employ while doing a precipitation reaction, so we discussed till now, but now we will understand in deep what are the theories, how the precipitation is going to form. So that is discussed in this session. So the formation of precipitate is a chemical process as well as a physical process. Both we can observe physical changes that is going to take place during the formation of the precipitate, as well as a chemical reaction is also going to take place while the formation of precipitate is going to take place. The physical process involves two steps. They are, one is nucleation and another one is crystal growth. Okay, so these are the two physical process which we are going to observe during the formation of precipitates. So now let us see one by one. So what is meant by nucleation? Nucleation is the formation of smallest particles of a precipitate capable of spontaneous growth. Okay, so let me take the example of the barium, which is going to get precipitated as barium sulfate when it is treated with the 1 normal sulfuric acid, which is called as a precipitant. Okay, so here when barium chloride is added to 1 normal sulfuric acid in a dropwise manner, so what happens there is the formation of smallest particles of a precipitate which is capable of spontaneous growth is going to happen. So this process is called as nucleation. Okay, so nucleation is the formation of the smallest particles of a precipitate capable of spontaneous growth. So the large cluster of ions can join in a supersaturated solution to form a nucleus, and this process is known as spontaneous nucleation. So what happens when we go on adding barium chloride solution to sulfuric acid solution? So there we find a large cluster. Large cluster means these smallest particles which has been formed during the process of nucleation. These smallest particles, they join together, they form a group and they form large cluster when it is a supersaturated solution. Supersaturated solution means so when barium chloride is more in concentration than compared to the sulfuric acid which has been taken. So that is what is called a supersaturated. That means the barium chloride has reached its saturation level. That means how much of barium chloride can be precipitated with that sulfuric acid which we have taken. So that much amount is crossed. Okay, so when barium chloride is added in excess, to say it in simple words, when barium chloride is added in excess compared to the sulfuric acid which we have taken, so then that particular solution may be called a supersaturated solution, and these large clusters of ions which can join together, so they are called as nucleus, and the process which is going to take place, that process is called as spontaneous nucleation. So formation of sites can attract ions which will act as a centers where nucleation and crystal growth occurs. Okay, so there will be a formation of sites. Formation of sites means so different nucleus are going to form in the solution, and these will attract the ions which will act as a centers which nucleation and crystal growth occurs. So this type of nucleation is called as induced nucleation. So this is how in the physical process which is called as nucleation, the precipitates are going to be formed. And the second method of a physical process is a crystal growth, and it is the deposition of the ions from the solution on the surface of solid particles formed in nucleation. Okay, so crystal growth means so here in the first step, when we add the substance or the sample to the precipitant, that is when we add barium chloride dropwise to the sulfuric acid, so there nucleation is going to take place, and the crystal growth is the deposition of ions from the solution on the surface of solid particles which is formed in the nucleation. Crystal growth takes place after nucleation, and deposition of ions on the surface of the solid surface depends upon diffusion rate of the ions. Okay, so the diffusion rate is influenced by the nature of ions, what sort of ion it is, whether it is a cation or anion. So by looking at the nature of the ions, the diffusion rate is going to depend upon, and the concentration of ions, rate of stirring. Yeah, this is very very important in precipitation method, or while doing the precipitation, the rate of stirring is very important. Okay, so that avoids co-precipitation, and also so forming of different large clusters, which may in further analysis lead into the impurities. So all these things will be avoided if we control the rate of stirring. Okay, the rate of stirring should be uniform. So for that purpose, so in advanced research we are going to use magnetic stirrer. We have got an instrument which is called as magnetic stirrer, and the duty of that instrument is to stir it in a uniform way. Okay, in the organic analysis or organic preparations, we are going to stir it with glass rod. By using the glass rod, we are going to stir it, and the rate of stirring should be uniform. We should take care, and we should concentrate in this part. This avoids many impurities, avoids the formation of impurities. And next, the diffusion rate is influenced by temperature of the solution. This is very important. So some compounds or some substances, so they may dissolve or they may soluble when the temperature is increased. At a particular temperature, it will precipitate out. When the temperature is raised or temperature is decreased, so it may lose its precipitation form. That means it may get converted into a liquid state, or it may get soluble in the solvent which we are going to use for the precipitation purpose. Okay, so these are the 4 different points which influences the diffusion rate. Next, the rate of deposition of ions is dependent upon the following. Okay, the growth characteristic of a particular cluster, and concentration of the ions, and impurities on the surface. So these are the 3 different things where the rate of deposition of the ions is going to dependent upon. It is important to dilute the solution and maintain optimum conditions before precipitation to promote nucleation and the formation of large crystals. Okay, so before doing the precipitation analysis, we have to maintain the optimized conditions. Optimized conditions are the uniform rate of stirring. Okay, so there should not be irrelevant increase and decrease in the stirring. The rate of stirring should be equivalent, and the temperature should be constant. There should not be variation in the temperature, either increase or decrease in the temperature. And it is important to maintain the to dilute the solution and maintain the temperature. Okay, so before the precipitation to promote the nucleation and the formation of large crystals. And larger the crystal size, easier will be its handling. Okay, so if the crystal size is larger, so then it is easier for further analysis, further studies of that particular crystal. Okay, so these are the 2 different theories of precipitation under the physical process of precipitation. And next is coprecipitation. So during precipitation, some of the soluble materials present in the solution contaminate the precipitate. Okay, so this is what I told, coprecipitation. So to avoid coprecipitation or to minimize the coprecipitation, it is very important to maintain the rate of stirring. So rate of stirring is going to avoid the contaminate of the precipitate. Okay, so the soluble materials which are present in the solution, so they will contaminate the precipitate if they cannot be removed by washing, are said to be co-precipitated, which cannot be removed in the further purification process. While doing the purification, that means when we are going to wash the precipitate which has been formed, so it is very difficult for us to remove that. since it has been contaminated in the solution along with the precipitate. So due to that reason, so it cannot be removed by washing. So such precipitates or such substances are called as coprecipitated substances. The process by which soluble impurities become incorporated into the precipitate during its formation is known as coprecipitation. Okay, so how the coprecipitation is going to form, and that particular process of formation of the coprecipitated substances, which we call as soluble impurities, which become incorporated into the precipitate during its formation. So that process is called as coprecipitation. Coprecipitation may take place in two ways, that is, one is a solid solution coprecipitation and the second one is adsorption and occlusion coprecipitation. So surface adsorption followed by occlusion is the more common cause of coprecipitation, but solid solution formation is easier and simpler. So now let us see one by one what is meant by solid solution coprecipitation. Certain substances when precipitated carry with them other ions present in the solution as an integral part of the crystal. Okay, so this is quite common when the ions which are formed as a precipitation, so if they are cations, definitely they will attract anions, and while formation of a crystal, so they will carry those anions along with them, and those anions also will be a part of a crystal which has been formed. Okay, so for that for in that particular crystal, so there will be a impurity. That means so the cation, so it has taken anion also along with it, and both those two anions, so they are going to form a crystal. Okay, so such substances are called as solid solution coprecipitates, and the process is called as solid solution coprecipitation. For example, so chloride by replacing bromide ions will coprecipitate with silver bromide. Okay, so this is one example where chloride is going to get replaced by the bromine ions, that is bromide ions, so it will get coprecipitated with silver bromide, and certain conditions must be satisfied for this to occur. So what are the conditions which has to be satisfied for the coprecipitation has to occur is, so the coprecipitated ions must be less soluble than replaced ions. In the above example, that is where the silver chloride is going to get converted into silver bromide, so there silver chloride is less soluble than silver bromide. For this reason, so the chloride is going to get replaced by the bromide ions, which in turn is going to get coprecipitated with the silver bromide. And the next point is the crystal structures of coprecipitated material and host crystal must be same. That is silver chloride crystal structure is isomorphous with the silver bromide. So because of this reason, so we can observe the coprecipitation in the formation of silver bromide. And the third one is the ionic radius of coprecipitated ions and replaced ions must not differ more than 10%. Okay, so the ionic radius also should be equal. If we study the ionic radius of silver chloride and silver bromide, so we will not observe the difference which is more than 10%. So that is why the chloride can get easily replaced by bromide ions in the precipitation of silver chloride to silver bromide. The contamination due to solid solution is reduced slightly by digestion or reprecipitation. Okay, so how to reduce this coprecipitation means digestion means heating the precipitate in a water bath or a sand bath by maintaining a constant temperature. Okay, so continuously we are going to heat under water bath or sand bath. So this process is called digestion, or we can avoid this by reprecipitation. That means by repeating the precipitation method. So by again we are going to dissolve the precipitate which has been formed in the solution, and we will start the reaction. We are going to reprecipitate it. So by this way we can reduce the coprecipitation. And next, the second one is adsorption and occlusion coprecipitation. So when large quantity of precipitants is added to strong solution of sample, nucleation and crystal growth takes place rapidly, which results in imperfect or very small crystals. Okay, so when we add large quantity of precipitants in a stronger solution of the sample, okay, so we have taken large quantity of precipitant, and to that we are adding a high concentration or a strong concentrated solution of sample. So then what happens, the nucleation and crystal growth will takes place rapidly, means in a very fast manner the nucleation or crystal growth is going to take place, which will lead for the imperfect or a very small crystals. For example, if barium sulfate is precipitated from a solution with an excess of barium ions, the barium ions will be strongly adsorbed, and coprecipitation is reduced by precipitation from dilute solution and by adding precipitant drop by drop with constant stirring. Okay, and next is a post precipitation. Post precipitation means it is the precipitation of an impurity after the main precipitate has been formed. Okay, so what happens is, first the main precipitate will be formed, and then the next reaction or the next step, once after the precipitate is formed, so impurity is going to be formed. So the post precipitation also introduces appreciable error. For example, post precipitation of magnesium oxalate on calcium oxalate. So this is one example. So in order to prevent post precipitation, acidity must be regulated carefully, and the ions which are likely to be post precipitated should be protected by complex ion formation or masking technique. Okay, so you need not to worry about what is meant by masking technique. So all those things you will study in next classes. How to prevent the post precipitation, if you understand that, that is enough. So acidity must be regulated. To avoid post precipitation, we have to maintain an acidic condition, and the ions which are likely to be post precipitated should be protected by a complex ion. We should protect it with the help of complex ion formation or by using masking technique. So this is how we are going to avoid the formation of post precipitation. Okay, so post precipitation means what? Once after the precipitation is formed, so there will be a chances of formation of impurities. Okay, so the precipitation of an impurity after the main precipitate has been formed is called as post precipitation. Now we will see what is the difference between co-precipitation and post precipitation. So contamination decreases with time in co-precipitation. So the contamination will decreases with the time, whereas in post precipitation contamination increases with time. Contamination is not enhanced or on agitation, and contamination is enhanced on agitation. And in co-precipitation, extent of contamination is least and extent of contamination is very large in post precipitation. So these are the three differences between co-precipitation and post precipitation. Next is the advantages of gravimetric analysis. So the procedures are very simple. Okay, so what and all the procedures which we are going to do the gravimetric analysis? They are very simple, and accurate determinations are possible if we use very good balance for the weighing purpose. For some 3-digit or 4-digit balance, definitely we can measure or determine the mass of the substance in an accurate manner. So that is why accurate determinations are possible in gravimetric methods of analysis. The interference by other ions can be minimized, and the equipment needed are cheap. The specialized techniques are not required. So these are the advantages of gravimetric methods of analysis. And the disadvantages are, procedures in some cases are time consuming. That is, so when post precipitation or co-precipitation occurs during the formation of precipitate, we have to repeat the experiment, that is reprecipitation has to be done. So then it takes too much of time, so that is why procedures in some cases are time consuming. There is lack of sensitivity, okay, so sometimes so while doing ignition or while heating it, so it may get charred because we will not be aware of the melting point of the compound, so we may heat it to the higher temperature, so the sensitivity is very low, and the accuracy decreases with a decrease in the amount of sample. Okay, so if we are doing it in a milligrams scale or low mass scale, that means the precipitate or the final yield of the compound is very less. If it is in milligram scale, so then definitely the accuracy is going to decrease. Okay, so that is what the accuracy decreases with the decrease in the amount of sample. So these are the three disadvantages of gravimetric analysis. So other than that, so it is a very good technique where we can measure the mass of the sample or the substance accurately, and the interference by other ions is almost minimized, and the equipment which is needed are cheap compared to other methods of analysis. So it is widely used technique which comes under quantitative analysis. Okay, so this main classification is quantitative analysis. So in quantitative analysis we saw volumetric analysis and gravimetric analysis, and so this gravimetric analysis is a wide technique which is used to measure or determine the mass of the compound in terms of weighing it and determining the mass of the compound. Okay, so this is what about gravimetric methods of analysis, and in my next class we will start discussing about instrumental methods of analysis. So how the instruments are used in methods of analysis, like we can use spectrophotometry, conductometry, potentiometry, polarography, mass spectrometry, flame photometry, like this. So these are the instruments which are used in various different methods of analysis. Okay, so we will see what are the instrumental methods of analysis and what are the advantages and disadvantages in my next class. Okay, thank you dear students.